minus 3.
Alright.
Then you go start minus 2.
Mm-hmm.
Then end 2. And then step 1. And then that should give you all the answers. I think you just draw it like that.
Yeah, so you can plot those points and then join them up.
Yeah.
And minus 2 would be minus 7. Plus 2 would be 1. And it should have a y-intercept of minus 3, and it does. Okay. So you're good for that. This one is a half x. How would you do that?
Is it just the same where you instead of 2 you just put half x, and then instead of minus 3 you put plus 3?
Yep. That's half. So we go. Oh, you get the idea. Just have to make sure you do put it in properly. Half x, 3x. Yeah, they're all the same. This time this thing is negative. Whoops. This thing is negative 3 minus 2x. Same thing, just put in the calculator. Okay, how about this?
So okay, so I think you need to do something like use the equation y equals mx plus c,
Mm-hmm.
and then you need to sub in 0 into the x bit and minus 5 into the y.
Okay.
And then m times or something times 0 is 0. So will the answer just be minus 5 for C?
Mm-hmm.
So will it be y equals 0x minus 5 or?
Well, mx minus 5, we have to actually find the gradient.
Yeah. So would I find 2 different coordinates of L1 to find the gradient?
Yeah, you could do it that way.
So if I did use like 4, 5 and 0, 2.
Okay.
And then I did 2 minus 5 over 0 minus 4 equals 2. Minus 3 over minus 4.
Mm-hmm.
And then is that the gradient?
Yeah, can you make it simpler?
3/4.
Am I crazy, or is it not going through 0, 2?
Oh, 0, 3. Sorry.
Yeah. So that was 3 minus 5. So what gradient did you get there?
Do you get a half?
Yeah.
And then is it just y equals half x minus 5?
Yep. X minus 5. Any questions there? I'll come back to this one just a sec. Line N is drawn below. Oh, did I forget the question? Okay. Okay, how do we do this?
So, okay, so A to C is 3AB. So does that mean that you need to find the difference between A to B?
Yeah, you could do that.
Is that like, do I just have to minus them from each other?
And no, because it's a diagonal line.
Okay.
Or, okay, go on, what were you thinking?
I was thinking if I did 5 minus 2 and it was 3,
Right.
and then 9 minus 3 and it was 6, and then if I just times that by 3,
And so what would you get?
so 3, 6 times by 3, so 9, 18.
So I believe that would be if it started from 0, 0. This one starts from 2, 3. Like it's 9 across from A. So what's its coordinate?
7. Oh, no. If it's 9 across from A, is it just 2 plus 9 and 3 plus 9? Or
So it would be 2 plus 9, yeah.
so would it be 11?
Yeah. And then the other one?
8.
Okay, so this blue one is 3 across, and so the red one is 9 across, and so 9 across from 2 is 11. And the other one, the difference was 6. So what was the y coordinate?
Is it 8 or?
So the difference between the y coordinates was 6.
So is it 6 more?
It's 3 times, just like this one.
I'm sorry, I think I'm confused. Sorry.
So the difference in the y coordinates is 6.
Oh yeah, okay.
And so this is 3 times more.
Okay, so it's 18.
Okay. And so what's the y coordinate of C?
Um, um,
So it's 18 higher than the 3.
yeah. Is it 21?
Yeah. That's it. Any questions about that?
I don't know.
So it's just kind of a enlargement of a triangle, something like that. Yeah, so it's just find the difference between them, multiply it by 3 and add it to the original.
Yeah, okay.
Perpendicular, lots of those. Okay, how do we do this one?
Okay. So, um, uh, so if they have the same, if they're parallel, it means they have the same gradient.
Mm-hmm.
So, do I need to substitute the 3 and the 4 in for x and y again?
Yep.
So is it 4 equals to 3 times 3 plus 2?
Not plus 2. It doesn't have the same C.
Oh, yeah, sorry. So 4 equals 3 times 3 plus 2.
Yeah.
And then it's 4 equals 9 plus 2.
Mm-hmm.
And then is it minus 5 equals to C?
Yep.
So is the equation y equals to 3x minus 5?
Yeah.
Okay.
Where's this one? You have to match these up. Okay. Okay. Which one matches with which?
Okay. So is um is e y equals to minus a half x plus 2y?
That one. E. Nope. What type of graph will it look like if it's minus a half x?
Would it be negative?
Yeah.
Okay. Um. Um.
So is there one y-intercept to 2 negative gradient?
Um. Like. Y equals minus 2x minus 2 has a negative 2 gradient.
No. That has a negative C. So the one you picked, this one in the middle, that has a negative gradient
Yeah.
and a y-intercept of 2. Is there a graph there, negative gradient, y-intercept of 2?
Um. Is that C or?
That has a y-intercept of minus 2.
So is it A?
Yeah.
Okay.
That's that
one. Okay.
And don't know if it makes it easier, but for these you could make 0 be equal to y, and that would also find the x-intercept if you were to solve it. Or you could just do it by gradient and all that.
Um. So is half x plus 2b.
Half x plus 2, and that's 0 minus, yep.
Okay.
So we only have one with a plus 2 left over.
So is that E?
Yep.
And then uh is minus a half x minus 2d.
Yeah, because negative.
And then is 2x minus 2f.
2x minus 2. Yep. There's f. And so this has to be C.
Yeah.
Yep. Okay, any questions there?
Oh yeah. How do you actually like work out like the lines through the graph?
What do you mean?
Like I only started like sort of realizing well which equation matches with which graph, but like for example when it has like the C bit where it's like minus 2 and plus 2, I don't really know like the difference between both of them.
So this would have a C of minus 2.
Yeah.
And then this one would have a C of plus 2. Because that's when x is 0. So that's when you get, when x is 0, you get y equals to C.
Okay. Yeah. Okay.
So sub 0 for x, or you can just even just see, you know, just by looking at it, that one's minus 2, that one's plus 2
Okay.
for the intercept. So that's drawing. More drawing. Okay, how do we do this?
Okay. I think I've forgot the step which we did before that, where we had to like where we had to like find like times or something.
Yeah, so this one doesn't have the distance. Any other way you could work it out?
Do I have to find the gradient?
Yeah.
So for do I need to find the gradient B of A first before I can find the one of C?
Yep.
So is it is it 0 minus 4 over 9 minus 7? And that's minus 4 over 2, which I think is just minus 2 over 1.
Mm-hmm. Which is just minus 2.
And then that times that's a big net box like.
Because they're on the same line, they'll all have the same gradient between them.
Yeah. So do I need to sub in all of this into like y equals mx plus 2?
You could do it that way. Another way, well, what would be the gradient between B and C?
And B and C. So 4 minus q
Mm-hmm.
over 7 minus 1.
And what do you know about this gradient between those two?
It's minus 2.
Yeah.
So I now need to rearrange it to get to q?
Yeah.
Okay, so if I did minus 2 times 7 minus 1.
Mm-hmm.
And then and then I think I need to expand the brackets of minus 2 semi minus 1, which is
What is 7 take away 1?
6.
Yeah. Make your life a bit easier.
Alright, so then 6 times minus 2. So 4 minus q equals to minus 12. And then minus q equals to minus 8.
If you subtract 4 from both sides.
Oh, sorry, minus 16.
Yeah.
And then q equals to 8.
How did you get 8?
Oh, 16, sorry, 16.
Yeah. That's it. So the trick with this is that the gradient between A and B is the same as the gradient between B and C because they're on the same straight line. So find the gradient between A and B and then make that equal to the gradient between B and C and solve it. Any questions there?
No.
Okay. I think we'll do those ones now. Let's take a look. Okay, how would you do this one?
Okay. Okay. So do I need to work out the gradient between A and B?
Mm-hmm.
Okay, so 9 minus 4 over 8 minus 2. That's equals to 5 over 10. So I think it's equals to a half.
Mm-hmm.
And then, so now, so the gradient is half x. Oh, do I need to sub in 156 again to see? Or,
Right.
and then is it 56 equals to half of 100 plus c?
Okay. So what C would you get?
Pardon?
So what C would you get?
6.
What would you do with that?
Um,
So you're kind of assuming that it's a half. How could you check that the gradient is also a half for a line going through D that also goes through A and B?
do I need to use A or B, A and B, and then find the gradient between them with D?
Yes.
So would I do like 4 minus 56 and or 56 minus 4 over 100 minus 2, and that be equals to 52 over 102.
So that simplifies down to 26 over 51.
Yeah. So does that mean that it doesn't?
Yeah. Same line, different gradient. Yeah. Any questions about that?
No.
So you don't necessarily need to find the plus C. You could do it that way. You could find the equation of the line between these two and then sub in 100 into X and see if you get 56 for Y. Might be just quicker to do it the other way. That one we're okay for. How do we do this?
So yeah, so to work out the gradient, do I just do 5 minus 2 over 3 minus 9, and that's 3 over minus 6 equals to 1 over minus 2, and then do I need to find the midpoint of the coordinates to something X and Y, or?
You don't. You could use any X and Y on that line.
Okay, so what I do, 2 equals to 1 over minus 2 times 9 plus C.
Yeah.
And then times the minus 1 over 2 together times 9, and then
So maybe.
so is it 6.5 equals to C?
Yes.
Okay. And then is the equation y equals to minus a half x plus 6.5?
Yeah. Maybe I should have left it as 11 over 2 because that one's over 2. Okay, so you don't need the midpoint. You can use any point.
Okay.
This is a good one. Okay, how about this?
So so am I doing C1?
Yep.
Okay.
Oh, sorry. C2, sorry.
Yeah. So is the gradient perpendicular to half x minus 2?
Yep.
And then do I do minus 2 times, no, sorry, so 4 equals to minus 2 times 0
Mm-hmm.
plus c. And then it's 4 equals to c.
Mm-hmm.
So just y equals minus 2 plus 4. Well, minus 2x plus 4.
Yeah. Well done. Okay, that's equation of a line. How do we do this?
Um, so do I need to now do x squared plus 2x plus 1, 2x plus 1 equals 16?
Say it again, sorry?
Do I need to times 2x plus 1 times 2? Do I need to just sub in 2x plus 1 into the y squared equation?
You could. There might be an easier way because they've already given you the graph of x squared plus y squared equals 16.
So do I just need to work backwards?
How would you do
Would you do y squared equals to 16 minus x squared and then square root it?
that? No. Never do that.
Hmm.
You would draw y equals 2x plus 1.
Y equals 2x plus 1. Okay. Um, so it goes through the one bit.
Yeah.
And it's positive. So does it go positive through minus 2 and 1?
How were you drawing these before? If it said, draw the graph of y equals 2x plus 1.
Um,
Like this.
oh yeah, I just sub into the calculator.
Yeah. And so, what goes in the calculator?
So y equals no sorry 2x plus 1.
Yeah. Where will we start from? Where will we stop?
Do we start from minus 4 because that's where the circle is?
Yeah, I'm gonna go for -5 just in case.
Okay.
And end.
Yeah, probably end 5 then.
Okay. Step 1. Okay. So -5 minus 9. -5. Oh, that's too much, right? Maybe we better do -4. -4 minus 7. Still too much. -3 minus 5. So that's okay. Just because the paper doesn't go that far. It only goes to 5 either side. And then 2, 5 is there. We said it has to have a y-intercept of 1. And it does. Okay. How can we use our line to find estimates for the solutions to those simultaneous equations?
So for So if we like took 2 coordinates from that line, what do we find the gradient? And then it should be 2.
Single gradient is 2. You don't need that though.
So do I do I need to use the line and then use y equals mx plus c to get to one of the equations, or
The solution is where they cross over. The coordinates are where they cross over. So there's one coordinate. There's one place where they cross over. It's approximately there. What does that look like?
about 1.4 and 4.8.
4.8 would be up here.
3.8, sorry.
And any other solutions?
Yeah, where they cross over, like in the bottom.
That's it. What does that look like?
Looks like minus 2.2 and minus 3.5.
Well done. Yeah, so we could have subbed one into our calculator and done all that expanding, factorizing, and solving. But the thing is, they've already given us the graph of one of them, so you can just draw the graph of the other, and the solutions to the simultaneous equations are where they cross over. That's where they both have the same x and y. Any questions about that?
No.
Okay. Okay, how do we do this?
Do I need to use my calculator again to find the thingy?
No. How did we just use a graph to solve simultaneous equations?
Oh, where they cross over.
Right.
So
So what did we do with this one?
when they crossed past the green circle.
So we first drew the other one. That one wasn't given to us.
So do we need to y equals x squared minus 4x plus 2? Do it like in the curve? Is that where it's crossed? Is that where you have to find the coordinates from?
Well, it has to cross over with something.
I'm not sure.
You would draw the line x plus y equals 6 and see where those cross over, because we've only got one drawn. So how would you draw that line?
You do x plus x squared minus 4x minus 2.
No. So that would be if you were solving it algebraically. So x plus y equals 6. What would it be if you rearranged it to be y equals?
6 minus x.
Yeah. And then you would just draw y equals 6 minus x. So your way would work algebraically, but it would, be long and difficult. This way, -3 and 9. That's up here. And the other one, 8 and -2 is approximately there. And then you draw that line. And so solutions.
So is right now I have to find the coordinates of the points.
Yeah.
So wait, is it when they cross the curve?
Yeah.
So is it for the one on the left? It looks sort of like -1.5 ish, and 5.8.
Yeah. And then the other one is something like 4.5. And whatever that is, 1. Something like that. Yeah, so the idea is, so if you have to solve two simultaneous equations, one way is you can use algebra, subbing one into the other. The other way is you can just draw both lines and see where they cross over. So one is a curve, and they already drew that for us. The second is a line. We draw that, and then we can just see where they cross over. And those are our two solutions. X equals -1.5, y equals 5.8, or x equals 4.5, y equals 1. And you can just write that as coordinates.
Yeah.
Any questions with that?
No.
So a different way to solve simultaneous equations is just to draw them both. So I got everything there. Okay, how would you do this one?
So just write it where I use the calculator.
Yep, it's a bit weird. 1 over x, start from 1, and at 7, and I'd just put in kind of the main, 0.333, that's a third. So 1, 1/2, 1, 2, 1/2, 3, a third, and then just join them up. And I'll make a curve kind of shape, something like that.
Okay.
This one, it's kind of transformations. I think it's not worth it. It only came up once. This one, this not really graphs. I might leave this one. Okay, we'll do this one.
So, do I need to show you? So does it need to go from 35 to 50, just like a straight line across horizontally?
Well, it starts at 30.
Yeah. 45, sorry.
Yeah. And then how do you find the end bit?
And then when it says at a constant speed, is that just like it just going through this computer 42 kilometers per hour. So um, so I need to do distance divided by time to get to 42 kilometers per hour.
Yeah.
And uh, um,
So we need to figure out what time they get home. So we know it's going to be something like that, you know, but we need to know what time they actually arrive home.
yeah.
How can you find time?
Distance over speed.
Okay. What's the distance? What's the speed?
Oh, right. So the distance is 21 kilometers,
Mm-hmm.
and the speed is 42.
So what do you get?
You get a half.
And what is the time unit?
Don't I need to convert that to minutes?
If you want.
30 minutes.
Yeah, so that's half an hour. That's 30 minutes. And so what do I do?
So do so if the distance is 21 kilometers, do you just go 30 minutes down? So does the graph need to end at 75?
Yes. So 30 minutes later, they return back to home. Okay, so for these ones, quite common that there's a rest period and then there's returning home. So they give you the speed, you read off the distance, and you divide them to get the time they arrive. Any questions there?
No.
Okay. Conversion graphs. Okay, how about this one?
Okay. So Jack buys 8 gallons of diesel. Okay. So if I converted them both to, I'll say, does it matter which one I convert it to?
No, just pick whichever works out to be easier.
Yeah, I think I'll convert liters to gallons. So I think I'll do, and then 40 liters looks like about 8.8 gallons.
Okay. Right.
And then Do I need to do 58 divided by 8.8 and 52 divided by 8? And then...
Yeah, that'd work. And then you'd see which one was cheaper per gallon.
Yeah.
Yes. Yeah, and it'd be fine. So, any questions with that?
No.
Sorry, 52 over 8, and then the 58 over 8.8. And you'd go from there. That's fine. I forgot the grid. Or did I? It's weird. No. Okay. How would you... If there were some blank squares, how would we do this one?
I just need to make C on its own.
No.
I'm not sure what to do.
So this would be like this exact same thing as drawing the graph of y equals 1.8x
Oh, yeah, plus 3. Okay.
plus 32. And so you do the whole thing. 1.8 of x plus 32. And so unfortunately I forgot to copy and paste the paper. The grid. But yeah, you could put in a -3 plus to +3 and go from there. Check that it has a y-intercept of 32. Yep. Any questions about that?
No.
Okay. And then this one, transformations of functions. That's not transformation of function at all. Okay, how do we do this?
Okay, so would I do? Okay, so for the 100 bit it goes to 25, and then for 300, do I need to do 40 minus 25 to go to up to 300? Is oh no, it's 45 minus 25.
So that's 345. Okay. So what about those?
And then if I get could I add them together and then just get 500 as well, and then add that as well to get some units.
Okay. That might work.
So
And I notice there's a 600.
yeah, I could do that for 345.
Okay, so what would you get with that?
Would that be again 125, and then I do 500 as well.
Okay.
And so then is it 125 and then 565?
Okay. And then what would you do?
We'll add them all together.
All right. What would you get there?
I'd get 900 and would I get 135?
Yes. I just want to check. So this was 65 minus 25. That's 600 minus 100. So I just want to do it a different way. Find the equation of a line. Minus 100. So that's 0.08. So 100. No. Sorry, 25. 0.08 E or something. And so 25 plus times 900. 97. And a slightly different one. So let's say for if you use 600, 65. That's why. That should be 600. I would do this using the equation of a line, maybe. Oh, maybe you're right. I don't think so. 25. So I do this using the equation of a line. The equation of this line. So 600 at one rate and then the other rate. I'm not sure. I'll trust you. I'll trust that you're right. I'm not sure about my method. Anyway, we got most of it done. Yeah, how was that for you, Andrey?
Yeah, that was good, thank you.
So we did the shape. No, we did, yeah. And now we did the geometry, and now we're just moving into shape. So we got about 2/3 of that done. So do you want to continue revision next time or something else?
Yeah, continue revision.
Okay. Any questions for me in general?
I think I should probably just mention that I got my GCSE result back on Thursday, and I got a grade 7. So
Yes, brilliant.
yeah, thank you. No, I just want to say thank you for that because, obviously, I give credit to these lessons because my teacher definitely. I don't give credit to my teacher, but still, thank you. I'm going to try to redo it though and get an 8 in the summer if I can. But yeah.
Oh, brilliant. Yeah. Well done, Andrey. You did great. I look forward to talking again next week. Well done on your result.
Cheers. Thank you. Bye.
All right. Have a good one. Goodbye.